There, you're welcome back to my channel. In this tutorial, I'm going to be teaching you how to build your own tokenizer for Gen AI. Pre-processing text for the Gen AI word embeddings. What you will learn from this tutorial. Content of this tutorial. You are going to learn how to load raw data. Working with file system. Raw text tokenization. Remove white space. Create vocabularies. Encode user text. Decode the encoded user's text. Concatenate the decoded text. As you can see, for example, when user enters text, which is a string of characters, such as "this is a boy," we are meant to have, okay, let me edit this. All right. So you can see that the output of this tokenizer is what we can see at the right side of the screen. Let's proceed. Let's jump into load raw text. These are the methods by which we can load the raw text into the program or code that will help us tokenize the text. The first method is input through terminal. So the mode of this tutorial is to check the technical and go into coding it. So the second one, we have load text file using open method, which is a primitive method from Python. The method from Python. So let's go into now, how to load data inputs. Load raw text using terminal. Here in the Visual Studio, I have a folder called LLM. Let's create a new file. Let's call it Tokenizer. .py. Good. Following the instruction, user underscore input is equals to input enter text here. User underscore input equals to input enter your text here. Okay, let's run this. I open the terminal, and to run the program we use Python, then the name of the file, which is tokenizer.py. Then press enter. Can you see? Here you can enter "this is a boy," full stop. Can you see? So we get it from here. Let's print out it. To print out, we have a method in Python called print. So let's print out what user enters. We can say, here is what you entered. Okay, let's do that again. Let's run the file again. Good. This is a boy. Full stop. Can you see it now? So we can collect raw data through terminal, which is what we have done. Good. Let's look at the second method. Load text file using open. You might have a file in your computer. So instead of us entering our input from the terminal, we can equally load our file. Let's create a file here. Let's call it sample.txt. So we're going to be putting this is a boy. This is the boy. The boy is a okay, the boy is a child. This is a boy. The boy is a child. Well, this is just an example. Now we have a file here, sample.txt, meaning text file. So we want to read out what we have in there. Let's clear the terminal. Now, how do we do that? We use with open as file. Then we can read in. We can say user input is equals to file.read. Then let's print out the user input. User input. Okay. You can say here is what is in the file. All right. Now the open we supply it takes arguments. As you can see, it takes file, that's file description or path. It takes the mode, is a string. It takes the buffering and also encoding type, errors, new line, and close field. But what is important now is the mode and the file path. So the file path, we have it in the same folder with the program, Tokenizer, as you can see. So what we just need to just supply the name and the extension. Then the mode is to read. By default, read is by default, but however, we can supply that. Okay? You can read more about that on the Python documentation. You can read that in the Python documentation. All right, let's run the code again. Can you see? You say here is what is in the file. The boy, this is the boy, this is a boy. The boy is a child. Let me increase the, can you see it now? Okay, so this is how to read file or to get raw data from, let's comment that, loading raw text. So the first method is through terminal, and this second method will use open method from Python. Okay, let's proceed. So we are done with the first slide. Let's move to the second slide. Tokenize the text. Now, if you remember, our content of tutorial is to load the text, which we have done. I believe you can do the same. We first of all look at entering text through terminal, and we equally look at reading raw text through open method. Okay, so now the next thing we need to do now is to tokenize the red text so as to get what we are looking for. Now, tokenize the text. What is tokenization? Tokenization is the breaking of text into chunks or list of tokens or words. So, it means splitting raw text into list of tokens or words. This is the process called tokenization. So to do that also, we have two ways of doing that. We can hard code it, or we can use a library called regular expression reg in Python to do that for us. So let's look at the first and the second. So I'm going to rename this file. I'm going to call this input. Good. Then the second one, I'm going to be calling it tokenize. Tokenize. Tokenize.py. So we want to tokenize the text that we read. To do that, let us we don't want this to run if we are not in this file. If we are not running this file, we don't want this to run. That is, we don't want this print to run. So if you can see this input now, we're going to be importing it so as to use the user input from this place. So let's look at it. From input, import user input. So let's try that out. Let's say print inside tokenize file. So let's do that, user input. So let's see it work. Let's see it work here. So now initially, if you run, let's run the input file. Input, that's Python, input.py. Can you see? Can you see? Say here is what is in the file, not from here. So let's run the tokenize. Let's see what that will give to us. Tokenize and run it. Can you see? It says print inside tokenized file. You will see that this escape this. So this will only run if you run the file from the terminal, but else it won't open. So it won't run that. So let's do the same for the tokenizer. Now, having access to the input user, the input, now let's work on that. We can equally do the same here. name dot space, that is because we're going to be needing this tokenize also in the second phrase of this tutorial, which is remove white space. So let's do that now. Let's split the input. So splitting the input, let me define the method, say tokenize. Then in tokenization, we're going to be returning user input dot split. Split. We are splitting with what? Space. When we see display, we chunk it, we break it, we cut this off, and we return the word only. So let's do that. Print tokens, or you call it words. Okay, then let's return let's call the method, which is tokenize. Let's run that again. Good. Can you see it now? Tokens. This is a boy. The boy is a child. However, if you look at these tokens very well, you will see that the boy and the full stop, which is the period, they are together. So you can see that this is very, very limited. So let's go to the second way of doing that, which is by using reg library. So it's third-person library that we're going to be deploying to help us split the word in irrespective of punctuation, and other special character that we might have in the text read. Okay, first and foremost, let's import the reg library. Good. Then in here, let's comment this. Let's say return .reg.split. So if we use split with special character, let's see what that will give to us. Can you see? It does the same thing as the former one. But however, when we supply all these special characters that we might expect this might have, let's add, let's say or, we are grouping it now. Let's say or full stop. So let's see what that will give to us. Can you see? It removes the full stop, but however, return an empty string. So in order for us to undo that, let's put this, let's group this bracket means to group. Group means split the source string by the occurrences of the pattern, returning a list containing the resulting substring. So let's check that out also. Now you can see we now have period in there. Okay, so let's just copy all this pattern. Let's copy this pattern and drop it in here. Good. Now this is double dash and single dash. You can read about this regular expression in Python documentation. So let's look at what this will give to us. Let's clear the terminal. Run the tokenization again. Can you see now? We now have the list of tokens. This equally preserve the white space in between those words. So let me print the word as well so as for us to see. Raw text. Let's say user input. Okay, let's clear the terminal and run that again. Can you now see the raw text and the tokens? This is chalked. It's cut off, and this white space in between also is preserved. Then we have her. The white space in between the is and her is also preserved. We have a boy also, and full stop is also conserved. So these are all conserved. However, we don't need this white space in this analysis or in the LLM. We don't need this white space. So how do we undo that? That leads us to the next topic that says remove white space. I believe now you can load raw text. Can you see how to do that again? We did that by reading the text file, which could be the big files. And also, you see the process of doing that. So this is not necessary. However, we do that in order to see what we have done. So we import this file inside this tokenize so as to break each phrase of this tokenizer. After might, we're going to merge all together. So the first step is to read, which is the input. The second is to tokenize, which is to chunk the entered value or the read content of the file into list of tokens. The next thing now is to remove white space. So let's look at how to do that. Remove white space, that is cleaned tokens. So to remove white space, we're going to be using another method in Python, which is associated to string value. So string has a method called strip. It removes the white spacing from the start and from the end. So let's look at how we can achieve that as well. So let's go back to our code. We're going to be creating remove white space, or let's call it white space dot py. That's Python extension. Now we are removing white space from the result of the tokenize. So let's import tokenize from tokenize import token. Okay, good. So let's print out the result from here as well. If names, okay, let's print out that. Let's say print tokenize. So it's a method, and that method is expected to return a list of words. So let's run that. We call it white space. So let's run it. Can you see it? It gives us the result of the tokenized file. So having access to this, let's now create a method called remove white space. Remove white space. It's a method. Remove white space. So now we can say return. Let's first of all say tokens is equals to tokenize because we know that tokenize will give us the list of tokens. Then to remove white space, we can now say clean tokens is equals to, we're going to be using list comprehensions to do that. So for token in tokens, let's see what that will give to us first. Let's remove this. And let's say return clean. Yes. So tokens, we are using list comprehension, which does the same thing as for loop. So let's print out that. Let's see that exit. Clear? So let's print out remove white space is a method. Let's call it in here, and let's run that again and see. That's Python. The name of the file is called whitespace.py. Can you see? Nothing changes. So to remove the white space, we can add condition to this. If token dot split is not none, so this return either none or return the value of the text. You can read more about that. Under the string method in the Python documentation. Let's see what we have now. Good. You can see it removed the white space in the list we have previously. Can you see it now? So we can proceed now. Okay? Good. Let's go back and see that we have achieved this also. We've achieved we now know how to load raw text tokenization, remove white space. Now let's see how we can create vocabularies. Okay, vocabularies that we have in the dictionary, we used to have key and value, that is the word you are looking for and the meaning. So here we are going to be using the token. Each token is going to be the key and the value is going to be numbered, okay, like we have here, like we have in this output. So let's proceed and see how we can achieve that. Create vocabulary. Map tokens to numerical values, that is tokens to indexes. Now let's do that also. Let's create vocab.py. So what do we get from there? We are importing white space. From white space file, import, what are we importing? Remove white space method, so as to get hold of that. So let's say create vocab. So to create the vocab, let's say tokens now is equals to remove white space, which gives us this list. Okay, it gives us this list, right? However, so in order to have distinct token, we need to reset this. We need to pass this list into set. Set will return distinct word to us. It will repeat itself. Like in this case now, we have is appeared twice, appeared twice, boy appeared twice. So these are not needed. In dictionary, you can't have one word appear twice, except you have their meaning appear what? More than one times. Okay, so to do that, let's print out this first and see what we're talking about. You can say create vocab. So let's say return tokens first. Let's see what we want to return tokens. So let's run that and see. We are not running white space now. We are running all right. What we want to run now is what? Vocab. Good. As you can see, it returns an object. Why? Because we are not calling the method as we ought to. Let's run it again. Can you see it now? So it gives us what we have from the previous file. So this is not what we are looking for. So first and foremost, let's pass this list to, let's say, get distinct tokens. Okay, to do that, we say, let's say distinct tokens is equal to set. Is a method also in Python. You can look up for that. So let's now print out distinct tokens and see what we're going to get from there. Good. As you can see now, we now have one D, we have one full stop, we have boy, we have child, we have this, we have is, and we have her. Okay, now we have a distinct word. So now let's map each distinct word to numbers, because according to what we have now, map tokens to numerical value, that is tokenized to tokens to indexes. So let's do that. Having gotten this, now we're going to do this. Let's equally use let's call it vocab is equals to token ID for tokens for ID, comma token, and enumerate distinct tokens. Don't worry about that. So it's list comprehension. We are using object comprehension here also. So let's return vocab. I will make the slide available to us as well. So can you see? Now we first of all remove the white space. We've got the list from the remove white space. Then we get each distinct word in the list. Here we map the tokens to ID in order to have what we have here. Okay, now let's go back. We have learned how to load raw text. We have learned how to tokenize. We have learned how to remove white space. Now we are creating vocabularies. Okay, so let's check that out first. Good. As you can see, this is assigned to 0 index, 1, 2 full stop, and this, and this, and this, and this. Okay, let's continue. What's the next on our content? Having created the vocabularies, Now we want to encode user input for the subsequent value entered. So that is encode subsequent user input, real-time text to index. So from the right hand side, we have tokenize underscore text is equals to refers to, so meaning that whatsoever user is entering as on the real time, okay, doing the real time experimentation, is going to pass through these processes, the process 1, process 3 and process 4 in slide 3 and 4. Also check if the token of the new input is found in the vocabulary, because most of the time the user vocal or the text or the word in the new input might not be found in the dictionary. So how do we handle that? We're going to learn that as well. So here we say encoded text. Now let's go and see what we are talking about. Let's create a file and call it encode.py. Here let's say user inputs. Let's say real time inputs is equals to inputs. We've learned that already. So enter your text. Good. Now let's run that and see. Run encode.py. So this is my text. Okay, can you see we can now enter now. Now before then, let's import our vocabulary. So from vocab import create vocab is a method. Then here we can now get that. Let's say vocab is equals to this. So let's try and print that out also. Vocab. So we have our vocabularies, and let's say this is my text. Good. Now let's work on that. Let's create a method called embed. Encode. So vocab is equals to create vocab. Now, and we call it what? We call it encode text. Encoded text or encode text. Anyhow, equals to text listing. We are using list comprehension too. For text, for token, in the user input now needs to pass through the slide 1. Can you see now? We need to go back to slide, is this slide 3 now? Yes, slide 3. That is, it should be slide 4. Yes, tokenize, and also slide 5 is because of this slide I added. I've changed the numbering. So we're going to pass through this first one, tokenize and remove white space. So let's do that. Meaning we're going to be importing that as well from tokenize import tokenize. That should be the method. Let's check it again. Yeah, that should be the method. Then white space also. From white space import, let's see the method, remove white space, remove white space. Good. So that is going to be done on the user input. Let's do it one after the other. So this is the user input. We create the vocabulary, then the user input at read time. So it should pass through, let's say, the new input now. Let's say input is equals to tokenize, then pass in the raw input. Then let's remove, we're going to remove space. That's input again. Input is equals to remove white space underscore input. Good. Now let's print out what we have now. Let's print it out. Print out inputs. Let's call the method. The method is if. Let's do the same. Now the method is encode. So let's do that again. Let's run it. So this is my text. Good. We have an error that says tokenize take 0 argument. It takes 0 argument, which is correct. So let's see what. Okay, let's copy this. I know why that happens. We're going to see that when we are putting us together. Okay, so here, let's drop this again and put this in here. By the time we bring all together, you're going to see the beauty of that. Then import the reg in this file as well. Import reg. Good. So white space as well, we do the same. So we need to equally use this also. The list comprehension to remove the white space in our encode value. So this is going to be underscore input. So now let's run it again and see. Let's clear the terminal and run that. This is my text. Good. You can see it now. Good. All right, now let's now map the word. You can call it, let's see what we call it here. We call it tokens to indexes. Let's do the same. Tokens to indexes is equals to this. So we are going to be checking the word in our dictionary. So let's say for word in underscore inputs. Don't forget that. We have done that before. Word. So this word must have the indexes. Is it the index? No, it should be here. Yeah, encode. It should have the number. We should find it in the dictionary. If found, then get the value. So we are passing it as a key to the dictionary, then look up for the value attached to it. Okay, let's look at that. Let's call it, this is not token, it should be encoded text. So dictionary, we say vocab we pass in the word. So now let's return decoded text. So let's see that. Let's print that out. Now, let's say this is my text. You will see an error now. Good. It said this key error. Remember, there is nothing like this in our dictionary. You want to see that? Let's print out the dictionary out. Let's print our dictionary. Let's print it here. Let's say vocab. Let's see it. Let's run it. Can you see now? We have in our dictionary, we have what? This. So it's case sensitive. Capital letter T is different from small letter t. So can you see that now? So this is, now let's try the capital letter and see. This is my text. Can you see? It's passed through the this, that is, this is there, is there, but mine is not in here. So that is why we are going to be using what they call UIK in LLM. It's called unknown numbers. So we're going to be handling that as well. So let's look at that here. You say if let's check the condition. If word in vocab.keys else we're going to be putting UNK. So before then, we need to do the same, extend our vocabularies. So where can we do that? Here. We will extend our vocabulary here as well. So let's extend vocab to undo unknown values dot extend. Good. We want to extend our vocabulary to equally have the unknown value, unknown word, that's the UK. Let's put it as a string actually. This, then map to the last, that should be the last number in our token. So let me see that first. Okay, now not because before this, let's do it here. Let's add it here. Let's say distinct dot extend. So we're extending unknown, and also let's extend another tokens. That will be EO end of file, EOT end of file. Yes, and let's use capital letter for this also. Yes, good. So we're going to do that for this as well. embed. Don't worry, by the time we are creating the full tokenizer you are going to get, but follow this closely. So we have this now. So if word in keys, then we find this. Else we return this. Okay, let's check that out now. Extend. Set object has no attribute extend. Okay, let's go back again and have it done. Should where is that one? Vocab. Okay, so let's equally pass it in the text. Is a list now we are passing. List. Okay, let's try again. Set object has no attribute extend. Okay. All right, so let's put it in here. Let's remove this. We have to extend the list. List can be extended, so tokenize. So we should have it that way now. We have resolved it. Let's go again and run it. Good. Can you now see it? We now have EOF to be 4 and unknown to be 8. So now let's look at that. This is my text. So the word that the dictionary does not have is going to be mapped with this, with the unknown. So let's look at that. Enter. Argument of type. This is not iteratable. Oh, okay. Oh, where is it again? The encode. Okay, key is a method, so let's do it that way. Good. This is my text. Good. You will now see it now that this, which is the small letter of this, is not found, so it changes it to unknown. And the one which is known, which is known. Is number 1, which is this. Then this also unknown, my is unknown, and text is unknown. Can you see it now? So this is how we have encoded the text, and what we expect now is we are expecting, so this is what the user entered. So we can convert it back to the normal word. Okay, so but however, in ChatGPT 2, any unknown word are represented by UNK. But can we equally keep track of our own word? Like in ChatGPT 2, they make use of I've forgotten now. So okay. All right, let's look at it. Let's proceed. The next thing we want to do now, we have encoded the word. Let's look at another word. Let's type another thing. Let's say this is SPaICT Hub. You can learn all that computer science department will teach you in school at SPaICT. So let's look at that. Can you see it now? These are unknown values. Instead of having break and our error, it will just map it with the word unknown values. Okay, good. And of course, if you want this unknown to be number, what we need to do is to just come here. Let's come here. Else we can just say this, pass this unknown into the vocabulary, then it's going to give us the number. Let's see it now. Let's copy the text I just typed in now. Okay, let's paste it. Good. If I run it now, can you now see it now? The unknown in our dictionary, the UKN in our dictionary is, let's see that. This is the dictionary we have. The unknown is 6. Okay, if it's not in the key, if it's not in the key, let's think about this very well. So if it's not in the key, okay, if not in the key, else, if not in the key, word is equals to this. Okay, let me try this way. Let's use, instead of using string comprehension, let's use this. Let's use normal string, this. So we have captured this one. So let's remove that one. But then let's create an empty coded text, an empty list wherein we're going to be adding this. So let's call this append. So we checked for the condition. If word in vocab dot keys, then encode dot append vocab, the value of that word now. Good. Else word is equals to unknown. Therefore, this vocab dot word. So we have changed the word that vocab was to unknown. So in order to get the value, instead of getting UNK, so let's look at that again. Good. Let's paste the value we got initially, and we expect, instead of having UNK, we should have the number now. Yes, 55555. So meaning that this is found. That's number 4. If you look at it very well, let me expand this. We're going to be having break. So this is found at number 4. we have it. Is number 7, we have it. Then the SPaICTHub is unknown. We don't have it in our dictionary. So unknown is marked as 5. So that's why we have 5 here. So full stop is number 3, which is this. Can you see? So every other word, you can learn all that computer science department will teach you in school at SPaICT. So you can see all these are 5, meaning they don't have what is it called? There's no word attached to them. They are not found in the dictionary. So that is it. So let's continue. We're going to have break on for that. So let's continue. The next thing now on our agenda, we have learned. Please go through this tutorial again. However, during the putting us together, when we get to this place, you're going to learn again. We're going to start all over again to put them together in Python class. So we have learned how to load raw data, which raw text tokenization, remove white space, create vocabularies, encode user text, and also decode the encoded user text. So let's do that also. Let's decode it. Let's decode the encoded value. Good. All right. Let's call that decode dot py. So to decode, we want to reverse. Let's read it. Let's read the decode. Where are we? To decode, we say index to tokens. That is, these numbers now, we want to convert it back to the word. Okay? We want to convert them to the word. Okay? So reverse vocabs key to values and values to keys. Decoded index is equals to, we are using list item also. List comprehension rather, we are using list comprehension. So this, and this. So to do that, first and foremost, we will need to reverse our vocabulary like what we have now. We are going to reverse it to from keys to value and value to key. Okay, now let's import that. Import from vocab. Do we have vocab? Import create vocab. Let's create decode. So let's say pass. Then let's say if namespace call the decode, print decode. Okay, now first thing first, we say vocab is equals to create vocab. So let's return that first. Let's see it. Vocab. Good. Let's print it out. Let's run it. Change this to decode file. So now we have the dictionary return. So what we want to do, we want to reverse this. So the token is going to be the value now, and the key is going to be the numbers. Okay, that's what we are talking about here. That is index to tokens. Let's look at it very well. Okay, reverse that. So we're going to say, let's reverse index to tokens is equals to is it list comprehension we should use? Okay, still reverse. So let's do that. ID token for token in items from ID token in items. So let's print out this one, the value we get from that. Let's confirm. So let's see that. Good. Now you can see excuse me, the value, the D should be the value O. We are getting what has happened to this. Okay. Let's print it out. Print vocab. Okay, let's see the encode. Let's run the encode. Good. So we have this is at number 8. His is 0. Okay, 2 is on no. Okay, correct. Now, but however, let's see the code. So meaning this is generating randomly. So what we need to do now is to bring the code together with the encode. Okay, so let's bring the code with the encode. Let's just copy this. Let's come in the encode. Good. So the encode get the dictionary value. So this dictionary now, let's bring it out of this method to make it a global variable that two methods can have access to, or any other method. So yes, good. Let's equally print it out and see. Okay, so let's print our encoded value to print decoded value. Good. Okay, let's run that. Oh no, encode. We have moved it into the encode. Okay, now this is my text, full stop. Good. Now we have 0, which is this, is number 5. Good. And my is not known, that is unknown. Text is not known, that is unknown. Then full stop is 10 or 8. Good. Then we now look at the decoded version is this is 0, which is correct. All is cool. So we have to change it. So key come before value. So we can say key come before the value of dictionary. So this is the correct way of doing that. So it's going to be value now, value map to the key. Yes, like what we just explained, key to value and value to key. So we now have it. Let's go back again and see that now we want to see number, then this is going to be the value. So let's go back and do that again. This is my text. Run it. Good. Can you now see it now? So we now have, if you go back here, we have end of file 0. So we have it. Good. It's now rhyme. This is this. Yes. How is 2, which is 2. Is 3, which is 3, right? 3 is now pointing to the value. Full stop is 4 and all. So we have interchanged it. Now, but that's not all. What we want to do is to decode encoded user input. What user has entered, I want to bring it back to life. Okay, so now we're going to be calling user input. So let's, inside the decode, we're going to be collecting encoded text. So we are going to pass in an encoded text in here. So let's say encoded text is equals to this. So don't let us call it so that you will not be confused. Let's just say hide this or indexes. So indexes. So now we pass in encoded text. Good. So let's print that encoded also. Let's print it. Let's call it encoded text. Good. Then this one is going to be decoded text. Decoded indexes. All right. Now inside this decoded, we are going to be changing the number. Now let's now look into that. Okay, so we use okay, this should be this. Then let's see, we call it decoded index. So decoded IDs is equals to list item. Let's use list comprehension. Why am I saying list item? List comprehension. Let's say word for index, rather, in ID for ID in indexes. Good. So let's return decoded IDs. So we have not done anything here, we're only returning decoded IDs. So let's say this is my text, full stop. So you can see we are returning, this is encoded text and encoded text. Is still the same thing that we're returning, but however I want to return the value. Okay, so to do that we're going to be looking into this dictionary, the reverse dictionary we have. So can I even call it reverse? Let me call it reversed vocab. So inside the reverse vocab we say reverse vocab, then we pass in this ID. So it gives us back the text that was entered. So let's say this is my text, full stop. Good. Can you see it now? This is my text. Note that this is unknown words, okay? This is unknown words. So that is why we have it this way. This is unknown word. Then full stop comes back again. Can you see the power of working with text now? So good, we have known how to encode, know how to decode. Now finally, from our contents of this tutorial, we have load raw text tokenization, remove white space, create vocabularies, encode user text, decode the encoded user text, which you have done. Then let's concatenate, because what user enters was this. So but we are getting list, so we want to join this together. How do we go about doing that? So let's create a, let's say concatenate. Let's define the function. I'm going to call it concatenate the decoded text IDs, or text, or how do we get it? Text. Okay, ID rather. Then how to do that? We say return space dot join. What are we joining? We're going to be passing values into this place. So it's going to be decoded IDs. So decoded IDs. So going to say decoded IDs. So that is all. That's the magic. So let's call it. Let's print it here. Let's say what's it? What's the issue? Okay, now let's call this one back to user inputs. Okay, so we're going to be calling what's the name? Concatenates. Good. But however, this we're going to cut it off and say decoded text. Paste. So that's what we're going to be using, decoded text. Decoded IDs rather, IDs. Decoded IDs. Then here, is too big, right? Can you see it now? Good. Decoded IDs. Then in here, we're going to be passing IDs. So let's see, let's go back and run the code. Okay, this is my text, full stop. Okay, we have issue here, say it's not defined. Okay, it's actually decoded. I did not encoded IDs. Okay, let's run it again and see. This is my text, full stop. Good. Can you see it now? We have the list. Then however, we go back to the user input, which is this is my text. So we say this is, can you see unknown and full stop. So the question now is, can we still take track of the former text, the former word that are unknown? Can we do that? Maybe after which we create our tokenizer, where we bring all these together, all this one, the input, the sample all together, and create our own tokenizer class. Then we're going to think about how we can, get the previous value that user entered. Okay, so before now, let's go on break. Let's go on break. Now we have covered load raw text, raw text tokenization, remove white space, create vocabularies, encode user text, and decode user encoded user text, and we have seen concatenate the decoded text. So meaning we have gone through this, we have gone through this, we have gone through this, and this. Then later, after our break, we're going to be looking at putting all the pieces together to build tokenizer class for Gen AI word embeddings. So this is the references. Build a build a LLM from scratch by Sebastian, okay, Reska, and AI Planet, where I got my certificate from, and also abusive comment on Nigerian Web 2021 publication. With I co-authored this as well with two other authors. But from the break now. Now let's put all the pieces together to build tokenizer class for JAIM word embeddings. Okay, we've gone through the phrases that, or should I say, the modules that uh, are constituted in tokenizer. So we've looked at the loading of raw data, raw text tokenization, remove white space, create vocabularies, encode user text, and also we have looked at decoding the encoded user text and also concatenation. So let's bring all these pieces together in a class, okay? Without further ado, let's get started. Okay, here is where we stop. Okay, should we run our program again? Let's run it again and see what we have here. Python, we are running the encoding file. Good, all right, we have that. Okay, let's say this is the day the Lord has made. I will made, full stop. All right, thank you. Okay, can we see that now? Encoded text, we have 4611115. So 111 is unknown word or no words. Okay, so then we go back to this. Don't forget, after which we implement tokenizer, I will give you assignment, and the assignment is going to be this one. Back to user input, I want you to read, instead of printing unknown, it should equally print whatever the user has entered. Okay, so I don't know, think about that, how to do it. I will equally do my own. Okay, so good. All right, Now let's build our full tokenizer class. So let's call that tokenizer. Tokenizer.py. Then the name of the class, we're going to call it spa tokenizer. All right, that's the name of the class. But before then, let's import reg. Import reg. I know by now you understand what that means. Okay, let me import import necessary library. All right, we need this library. All right, okay. And also, if you look at all these files we created, you will see, you will agree with me that vocab is general or is necessary for all of this, most especially the white space, I suppose to. Okay, of course, it's important for this, it's important for this and this. So because of that, that should be the class property. Okay, so let's use a method called init that enable us to set the class property. So here we're going to be setting vocal though. Okay, it's general for all of them, but however, this should take in we need user input first. Okay, let's just put to do. Okay, I think with that it will help us with what we need to do. So let's write to do list. Okay, let's put it in here. Excuse me. Let's list out what we want to do. Okay, I think to do, the first thing we need to do now is to, inside our SPI tokenizer, we're going to be getting the user inputs. That's the first input to build our dictionary. Okay, now we're going to be reading in, let me say, read in text document for building vocab. Okay, we need that one. We read it in to, like we have here, we have sample this one. So is this one that help us to build our vocab. So we need something of that. We need to read that before we collect subsequent input from user. Okay, then having gotten that, read in that, we are going to be tokenizing it. We still the same the same thing. So the next block is to tokenize it. Okay, tokenize the text document. All right, the next thing now, after tokenizing, then we remove the white space. Remove the white space. Okay, and also after removing the white space, what else do we need to do is to create the vocabulary. Create vocabulary. All right, then after that, what do? Encode. Then we implement encode method. Implement encode method. All right, now after there we go to the code, implement the code method, implement the code method. Then after then we can say, okay, print out. We can print out, right? Let's just say print out. That's although not necessary, but we can still do that. Let's say print the user input. All right, I think that's all for, yeah, that's all. So let's follow each of those. Okay, now this class, let's implement all the method, or before then we need, when we initiate the class, that is when we call the class, let's say tokenizer is equals to spark. So this is to instantiate tokenizer. This is to instantiate tokenizer. All right, good. We build tokenizer object. Okay, by showing this expected index. No. All right, why is saying that is because of this. Okay, if you let me say pass now, is the, can you see the error has gone? So let's do that. Let's just declare each method first before we excuse me, before we proceed. We can equally print a string representation of our object. Okay, now the first thing, reading the text. So we say get, okay, read in document. Let's just say it, let's put it like that, reading document self. Okay, let's put all of those first. Let's do that first. We're going to be implementing it. Then the second one, say tokenize, tokenize, okay, self. Then that self refers to the instance of that class itself, referring to itself. All right, remove the white space, create vocabulary. Okay, remove the white space div, remove white space, pass. All right, next we create vocabulary. Yeah, create vocabulary, def vocab. Let's just put create or generate vocabulary, either way, vocab. Let's just use vocab. Then self, pass. Then what's the next method? Encode, def encode, pass, and decode, def decode, pass. Then lastly, def print user input. Let's just say print user input, print decoded value. All right, I think we are good to go now. So now to read, this will say read in documents read in document. So to read in document, we can now use this tokenizer that say tokenizer dot read in file. Can you see? That takes in argument, and that argument should be what? The file path. The file path. Okay. It's going to be a string. So that is what we're going to do now. The file path. So that's argument, but in here we are going to set the parameter here. So comma, let's call it file name or path, either way, file path. So to do that, undo. All right, file path. Let's declare a variable inside the init. So we need to keep that value in here. So what should we call it? Okay, let's call it file is equals to okay, self.file is equals to none. Okay, no. Then here, let's read in there. So we can say with opened as f, then self dot file is equals to that. That's all what we need here. So with this, you will be able to read in this. However, we're supposed to wrap this inside try and catch an exception, because we have file error also. We have file error. So let's use their class, that's exception, or file not found. That's file not found. Okay, as he. So with that, we wouldn't want our program to break. So let's put in this here. Then what should we do when the file is not found? Okay, we should raise an exception. Raise file value error file. Okay, file not found error. Okay, let's try that out first. Let's see what we're going to get from here. Let's convert this to string, to e. Let's see that. Let's assume we want to read file that we are not supplying. Let's just supply a file that, if you supply sample now, we can read in the sample. We have it here already. Okay, but let's supply some things. Let's assume let's assume we want to read this in text and see what will happen there. So let's run the program. We have to run tokenizer .py. Let's press enter and see. Good. Can you see? It raises an error of file not found error. So it print out no such file directory. All right, let us make it. Let's print it out, the error ourselves. Instead of printing all of the error, we're going to do it ourselves and make this one dynamic. Dot format file path. Okay, let's run it now. See, let's run it. no such file directory. Let's just say error. Okay, let's just say error. Let's clear it again and see. Let's run it again. Good. We now have error. No such file or directory is found. Okay, or let's say file not found. File or directory is not found. Okay, let's remove this error now. Since we have the file error already printing out, let's see that. Can you see it now? File or directory is not found. So we have control over our program now. We ourselves, we can raise that exception as well, instead of it raising it for us. Okay, let's now read in the one we have here, the file we have here, which is sample. Okay, let's see what we're going to have, whether we're going to see an error. So no error. Can you see that? So let's try and print out the file itself. So to do that, I think, yeah, we can use underscore print ref string. So we can say return self.file. Let's see that. Let's see what we're going to have there. To do that, to print out the, let's see it's at work here. Okay, Python. Let's say it's import from Tokenizer, import Tokenizer. All right, let's say Tokenizer object is equals to Tokenizer. So let's pass in. No, we're not passing objects now. Good. Now let's read that Tokenizer underscore objects dot read in documents. All right, let's pass in the name of the document we have to read from. All right, yeah, we have read that in already. Let's try and see the method we've just created. That's dot underscore r print. Let's check that out. Okay, representation. Okay, so let's say that's repre. So it's a method, right? Let's print it out. Let's see. Can you see it now? So what we have in here, we have it already. So this helps us to print it out. So that's for the debugging aspect. So we can use it. So we can equally customize it this way. Make it something of this nature. I'm trying to remember how. Okay, let's use a spark. All right, let's continue. Okay, all right. Or let me try and do something. f string um curly bracket, so we can say file, or we can say file input. Okay, I think it's better this way. All right, so we have it now. So it won't work now until we exit this one and run it again. Python import, let's import. So let's create instance of that class and let's read in the text. Then let's see the print. Let's print it out. Can you see what we just did now? So file input, this is the board. Okay, we're going to be using a text. So let me just copy in a text, okay, so as to see. So we've successfully read in what information. So excuse me. So we're going to be using this. This is the document, the topic, one of the the topic I preach in the church. Okay, we're going to be using that. Okay, so let's use it as our sample text. So let me erase this and paste it. So we have bunch of streams of character, much more than what we have initially. So can you see it now? So if you run that, I don't think we can still get that. We need to run it again. So let's exit and run it again and see. Okay, let's in Python import the class, instantiate the object of that class. Then can you see it? Let me zoom out. Okay, good. Instantiate that. Let me close this panel, the explorer. Let me close this explorer part. Good. So I believe you can see it now, right? So we've instantiated that already. What we need to do now is to read the document, which is sample. Then we can print it out. Let's see. Let's now use print and see what we have there. It's going to be a lot of text. Can you see it now? So it's very much. So we're going to work on that. Okay, good. So this will help us to create our vocabulary. I think we need to write this vocabulary in a file as well. What do you think? We should write it in a file so as to have the track of it as well, so we don't need to be reading it all the time. Okay, however, let's just concentrate on building the text first, so let me make things complicated. All right, so please follow along. Now we've implemented reading in the document, okay, and we have catch all the exceptions so that our program will not break. Okay, now let's go ahead and create tokenizer. Let's tokenize the text read in. So because that is the next thing to do. That's the next thing to do. Having read the text, then we tokenize the do you still remember? You still remember the method? We use reg expressions to do that. Okay, so we don't need to do much. Let's just go to what we have here and copy some lines of code. Let me close this, open this. So this is the tokenizer, what we need. This is what we need. Okay, so and we need the input that the user enters. So we only need this. Let's copy this alone. Copy, then come into this place, and so we need a property or variable, class variable called tokens. which is going to be list of words. So now that's where we're going to we're getting that from here. So tokens, can you see it now, equals to paste that. Okay, however, this we don't have user input, don't forget. So we have what we have now is called file. Okay, what the user has already gotten via read in text. Okay, so we have that file, and also yeah, we have that. So now let's look at remove. Let's print, should we print that also? Let's print the tokenizer also. Let's print that tokenize. Let's print it. Print underscore self dot tokens. Good, let's do that. Let's see what that gives to us. So we're going to be doing that also. We can use this to do that, and equally we can, let's exit this. Excuse me. Let's do that from here. Let's run that. Good. Oh, all right. Oh, yeah, we can do that. So we call tokenize on this file. Let's see. Yes, we have read in that. So tokens, to see the output, let's say dot tokenize. Tokenize a method. Yeah, so now let's run it again and see it. Good, can you see it now? So it helps us to chunk the bunch of text we have from that files into that. So now the next thing is to remove what? To remove, we have read in raw text tokenization, which is the breaking down stream of character into chunks or token or unit word. Now remove white space. So when we implement remove white space, we're going to be going on break. Okay, so let's do that because I need to go and take my bath. Okay, now let's implement remove white space. So we've done that already, so let's come here again. So watch the video on that. Okay, now we have clean, let's say yes, tokens. So what we are going to be doing, we are not going to be creating another variable, but we're going to be working on Python enable us to, when you have used a token a variable before, you can reuse it again. Okay, so we're going to be using that tokens, but that token is getting from fx dot token, yeah, self dot token. Then strip out empty space. So this one will be empty space before and after. So we can now say, let's call it let's call it our tokens. Okay, self dot token again. Good, so let's see what that we produced. So self dot tokens. All right, so in Python, like I told you, we can use a variable. We can reassign values to a variable that have value already. Okay, so what it will do here is that it will first of all read the default value from the class which we have tokenized with this empty space and all. Then it's going to run this do the follow, check through the list of those chunks or tokens. Having done that, it is going to look for the empty space from the start or end or wherever, remove it, except when it is empty space, it's going to return false. But when it has some set of symbols, that are not empty space or space, is going to you know list it among the list. Okay, so this is what we call list comprehension. Instead of use for loop, you can use that. Then this will now serve as a new variable and store the new value. Okay, now let's do that also. Let's do that. I would have loved that we call this method. We should call this method inside tokenize. Okay, let's call it inside tokenize. We can remove this. We can remove this. Then we can say return. Yes, let's just say return. Good. And let's pass in value here. Let's say chunks. Okay, so it's going to be chunks, so that will not be a hair. Return chunks. So we call it inside tokenizer. Okay, let's call it inside tokenizer here. So we're going to be passing, so serve is going to be, let's just call this let's call this words. Okay, this will break the word space and all. So we're now going to call serve dot tokens is equals to remove white space, then pass the word in there. So can you see it now? So this one will return list of word without space. Okay, to access that method of the class, also we use serve dot remove. Okay, so that we don't need to be calling it outside here. We only call the tokenized method. So let's print out that as well. Let's print it out and see what we're going to have. Don't forget what we had initially. It was showing white space as well, but let's see what this will give to us. Okay, as you can see from the terminal, initial value we have. So let's see if those okay, don't let me clear it. Let me just run it so that you see the difference between what we have there. Okay, it says what? We have an error, type error, take one argument. Okay, so it takes one argument. So since we pass an argument in here, so what we need to do now is to, okay, we did not put serve. Okay, serve. Okay, it's very, very essential. All right, let's run it again and see that any method in the class, you have to put that serve or whatever, or this whatsoever stuff you want to put. Can you see it now? Good. So it has helped us remove all the white spaces that we have. Can you see all these white spaces we have initially were removed? Can you see? We now have words and other character, special character. Okay, like column, like comma, numbers are also included. Okay, so let's go on break now. We'll soon come back, and please go through what we have done. We have checked out, we have learned how to read in, we have done that before. Then we are creating a class to harmonize all of those phrases of tokenizer. So we have read the raw text. We have tokenized the raw text we read, and we have removed the white space. Now next thing is to create the vocabularies, but before then, please go through the slide. I'll soon be back. Okay, come back from the break. We stop at remove white space. Okay, now the next thing we want to do is to create the vocabularies. Okay, so meaning that we're going to be needing another class property called vocal. So that is going to be an object. So let's create an empty object for excuse me, an empty object for that. So now, yeah, we're going to be needing the tokens, okay? However, if you remember, in the tokenized.py that we did, or doing the, I could not remember, is it, okay, doing the vocal, we did something, yes, can you see? So we don't need to do this again, but however, we need to extend our tokens to equally contain what, to handle unknown number, unknown words and end of files, okay? So we need this, and also we need to equally get distinct um value or distinct word. Like I said initially when we started, that in a dictionary, in a normal dictionary, I mean the hard copy dictionary or soft copy dictionary, you can't find a word twice in a dictionary. However, a word might have more than one meaning. So a dictionary is it could be one to one relationship or one to many relationship, meaning key to value or key to values. So the same thing applicable to the dictionary we want to build for LLM. So if you have this, I mean in terms of, let's say in the dictionary you have this, yeah, you shouldn't have another one days again. One, it's okay. However, but for this dictionary, we're going to be considering this to be different from the capital letter T because they are case sensitive. Okay, so that's the only thing we're gonna do. Now let's copy this from here. We are done with this, okay? Okay, let's extend it. Let me just take you through it one after the other. Let's go to the build pass. Let's remove this pass now there. Let's extend our tokenizer to undo the other one, tokenizer dot extend. So what are we trying to do? We want to pass in two values, and those values are unknown words and unknown capital letter like this, and the end of file, so EOF. All right, so we're going to be extending that. Then we are going to be getting the distinct list of tokens, the distinct list of tokens. So I'm going to get that done now. Okay, okay, now let's do the same. Self dot tokens is equals to set. So set is a method in Python library, okay? So self, let's pass in that. So good. However, having done that, if you look at the var vocal.py, having gotten the distinct value, having gotten that distinct value, then we now, we map. Okay, no, let's go. We map, let's say, oh, sorry, I want to comment this for the later visitation. You might want to visit it later on. Okay, now let's look at vocal. What do we need to get that done? So you can see map tokens to numerical values. So that is what we're going to do now. So to do that, self dot vocal is equals to token map to ID for token for id in for id token in enumerate what? Sep.token. Can you see that now? Let's print the vocabulary out. Let's see. Print self dot vocab. All right, let's print that out. Let's see. We need to call that. Where should we call this? Great vocabulary. Okay, we're going to call that outside. Don't call it inside the token because we're going to be using that later. All right, good. Dot create vocab. So let's run that and see. Let's zoom up, and also let's remove the print inside the tokenizer so that we will not have all this place messed up. Okay, let's only put it in the create vocab. Let's clear the terminal. Good, and run the tokenize. Okay, we have an error here. It say non-type object is not iteratable. Non-type object is not iteratable. Non-type object. No. Okay, let me see why it's saying that. Inside line 41. Okay. All right, let's see what we did here. Extend tokenize. Okay, none. What makes it none? Excuse me. Okay, all right, let's do something of this nature. Let me extend the dictionary. Excuse me. Oh, excuse me, sorry. Sep dot this dot extend. Let's leave it that way. All right, let's try that again and see. Good, it works. Sorry for that. It's, you know what happened then? Initially, the token has been saved when we tokenized, but now inside the create vocab we now call the token variable again, then reassign another value. So this value is going to be is not going to return only these two value in here, so it override the subsequent value that it has. So we don't actually need to reassign. What we need to do is to extend. Okay, so that's the issue. Sorry for that. So you can now see now that each word are being mapped to value, the index. Okay, starting from 1 without. Okay, 1 2 3 4 5 6, and those extended words to, let's search for them. Where are they? Okay, can you see for the unknown is 215, and the other one too must be there since this is found there as well. That's EOF. That's end of file. So let's check. Let's look at it closely. And I want you to know that this word are distinct word. They're not repeating twice. Okay, yep. So let's see that one diligently. I am looking at it, and you equally look at it. Okay, let's look at it together. Okay, we are looking for the second word. We extend to word, that's UNK, which we have seen UNK, and I'm looking for EOF. Okay, this is UNK. We are looking for if I can find. Okay, good, I've seen it. That's EOF. That is 297. You know what I wanted to do initially? If I'm unable to find it, what I will do, I will just print it out, that one alone, like I'll say EOF. So that one will actually give us the result of sorry for that, it will give us the value straight up. Okay, look at it, let me show you. Can you see? It gives me 564. So if I trace 564 now, 564, it's very simple for me to actually locate now. 564, 5, 6, and 4 is a new value for that. uh, 564, excuse me. Oh yeah. 564 is the new value for that. Okay, let's print. Let me show you. No, this one we have here is previous printout. So let's print it out so that you see the effect of that. So if at all we are looking for that particular, this one that I was looking for, now let me clear the terminal. You see, it's very interesting. Okay, so I'm making sure that these error are, you know live, and I won't remove it in the editing. I want you to know that to become a programmer, not all the people, most people doing tutorial, they make it perfect as if you don't do commit error. Error is part of what that make you a proficient programmer. Okay, and the ability to locate the error, to identify the error and swiftly debug the error, makes you a perfect or proficient or good programmer. Okay, so it's cool. Okay, let's make it raw. All right, so and I want you to know this, what I'm doing now, I don't write it inside the book. I'm thinking alongside. Okay, so alongside, as I'm coding, as I'm teaching you, I'm thinking alongside with it. It's not what I have in the book, looking at the book. No. Okay, so make it natural, and I want you to get it. That's why I'm doing it that way. Okay, now let's go. Let's run this. Now we have the that one now is what, 457. So let's trace 457 and see. 457, 457. Here we go. Can you see it now? So you can see it's very, very cool. Okay, from that we were able to do that. So that is the end of creating of vocabulary, which we have done already. Okay, now the next thing to do to implement now is the encoding subsequent user input. Now let me give you assignment before we go further. Now this dictionary that we've created now, I want you to save it in a file. So using with, let me give you expo. Now using with, you can use something of this one, of this nature, as f. Okay, you can use that and write the name of the file name. Okay, I want you to go and go to python, python.org, wherever, and search for the documentation and read about it, how you can write. Okay, write, can you say write to file, or you want me to do it for you? You want me to do, okay, let me show you. So this is it. You just write, um there's a method there, you can say write. I think let's use write. Then you say self. What are we writing? Self dots is not token. We want to write this vocabulary in the file. So the name of the file now, let's call it vocabulary, vocab.txt. Okay, so if you run this code again, it's going to, let's run it. What is it saying? Argument must be string and not dictionary. Argument must be string and not dictionary. I think okay, CSV. Let's use CSV to write it. Oh, string and not dictionary. Okay, CSV. Okay, you want us to write it. Let's look at it together. uh right line, it should be string and not dictionary. We can use CSV to write this. Yes. Okay. All right. Go through it. I've forgotten that now. I've forgotten that. Like I say, you can see I'm not using internet to code. I'm not writing anything. I'm just thinking now. Okay, so that you know. Although it's good to do internet, but I'm just tasking my brain. Okay. All right. Good. We have to um three method left. Okay. Okay, let's look at it now. So having created the dictionary, now the user input, subsequent input. Maybe we have the dictionary, then you are bringing your own word. You want to, you want to, you know, that's how the LLM work. We have a dictionary already of words in the we call it vector database. So vector database, when you enter your own value, your current queries too must be chunk, okay, that is tokenized. Then save its IDs, then search, you know using there's a method. We're going to learn all of this one. You're going to build your own what's it called, LLM. You're going to build your own transformer. Okay, as time goes on, I have a lot of things I'm teaching. I might not teach it sequentially. I might be taking it randomly because I'm equally teaching web programming. Okay, so I'm looking at sponsors. Okay, sponsors that can equally help in that regard. I need a lot of equipment to put things in order. I will need board because I want this particular channel is going to be like a computer science library, or I mean lab rather, lab where we're going to be doing physical teaching on the board as well. So I need funds to actually get all of these things, procure all of these things. So, but however, as it stands now, let's take it one after the other. I know as time goes on, I'm going to get partner, I'm going to have sponsors, and I'm going to get uh, 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 get all of this equipment to make everything easy. Our aim or our vision in this channel is to give tools to everybody, because we believe that everybody has one of two solutions to the human computational problems, and if they are not having access to what they need to solve the problem, they might not be able to explore their capacity, their inbuilt capacity. And that is one of the zeal, that is one of the passion, that's one of the fuel that is pushing me, teaching you this thing without anything. And I promise you, I'm going to be doing my best to give you all that you need to know. Okay, let's continue now. Okay, now encode. So let's go back to the slide. Encode, we want to do what? Real-time text to indexes. So tokenize on underscore d underscore text refers to slide 3 and 4. Okay, we have done that before also. So I'm going to make this URL, I mean, the GitHub repository link available as well. So you can clone and go through the code and watch the video over and over again. Okay. Let's look at encode. Is there? Yeah, good. So the encode function we have here, good. Can you see it now? We collect this is a prompt from the user prompt, excuse me. So let's go through, let's do it. Let's implement that also. Let's re-implement. I'm going to be calling it prompts now. Okay, let's close other uh, file we have here. Okay, so now let's call it user prompt, user query or prompt is equals to input. Okay, instead of here, we are going to be collecting that outside. Okay, let's just here we're going to be passing prompts. Okay, let's pass in that parameter. So prompt needs to be tokenized. Okay, we need to tokenize the prompt. So now we can call the tokenization method. Yes, let's call it. We can call that method in here. We can say prompt is equals to self dot tokenizer, then pass in the prompt. So it will return that. Let's print out the prompt. Let's print it. Print prompt. Let's see that. Okay, now without that we need to call it. Let's call it tokenize dot prompt. But prompt takes it, you will pass in argument in that. The argument will be what user enter, so user query. So that one we're going to be using is either input field or text area when you are designing the interface. Okay, so let's say input, enter your query. Yeah, so good. So we pass in the user query. So now what else? This is showing white. Why is it showing white? Let's see. Is the name not correct? Oh, encode, not prompt, rather encode. All right, good. That's the method. Prompt is a variable. So now let's run it. Let's run that as well. Let's run. We have not done anything. We just want to do print out if the tokenizer help us to do that goodly. All right, clear the terminal. Oh, sorry. Today is my birthday, actually, August 23rd. All right. That by the way. All right. Good. So we have now, behind the scene, we have encapsulated the other one. We are not printing it to the console now. So it has helped us to chunk the file read in. That's from the sample. It has recognized it. It has helped us to create vocabularies. Then now it only jumped to line 60 that we should enter that and all. So let's see that. Let me just enter thank you, Lord, for the gift of life. All right, full stop. Enter. Good. We have an error here. He say take one argument, but two were given. Where? At where? So it should be inside. Okay, yeah. So let's see. The argument is talking about token. Token takes no argument actually. So why do we now give this? It does not take any argument. So I think it's good now that we pass in arguments. Or let me see how we can get that done. So that yes, we need to pass in arguments. So yes, let's go pass. Oh, no, I don't want us to pass argument. I don't want us to pass any argument. So what do I do? Okay, what I will do now is to replicate. So I don't want to be replicating this. How do I go about this now? I'll find a way around it. Okay, now this is what we do. Let me just create a EPA method. EPA method. Where is it? Okay, in here. Okay, good. and we create another method, tokenize. Prompt. Return. So not file, but rather prompt. Then, yep. So let me just say text. So text. Good. So we remove this. We are using the method inside us. Yeah, this is what we call wrapper. Okay, yeah. So we are getting there. Okay, now let's print that out. Let's print that out first before we proceed to do what we want to do. Actually, um, we're supposed to remove the white space as well. So let's remove the white space. So to remove the white space now, let me see if we need to put anything. Okay, just need to call the white space and it gives us the list of words. So is here, where should we do that? Okay, let's call it here. Okay, having called it, the result of this one, there will be prompt is equals to create remove white space. Okay, good. All right. Oh, it's going to be self, right? That's self we are using from the class. Okay, now let's run that and see. uh, Good. Okay, this, okay, thank you, Lord. That's what I used initially. Thank you, Lord. Thank you, Lord, for the gift of life. Okay, full stop. Good. We got it. Can you see it now? So we have, it has helped us with a chunk list of words, a chunk list, and it has removed white space in and all. All right, the next thing we need to do, we want to encode it, and encode means that we should pass through the three slide. That's slide one, tokenize, and also, so let me update this. It's not actually 3 and 4 again. It's 4 and 5 because I've added one slide up before them. So yeah, 4 and 5, that's slide 4, tokenize and remove white space. All right, good. So now we now say if each token of the new input is found in the dictionary, we should check. Then we should do this. So this is what we want to get. Okay, let's do that now. So now that we have tokenized, we have removed the white space, then we need to encoded prompts is equals to encoded prompt is equals to, let's do list comprehension. So for, let's say, uh, words or word in words or prompts, that's chunk for chunk in prompts. So it's the prompts that we have now. We are still using prompts. So prompt that is a string of character, now we have changed it to the list of words. Okay, so we are passing it here. So now we are going to be searching for that as well. So in our dictionary, don't forget the dictionary, we have it vocal, then pass the key. Chunk is going to be the key and give us the value of that. And also we need to check, okay, we don't need to check space again. We have removed white space, so we don't need to do that. So now we need to print our encoded prompt. Okay, let's print that out and see. Thank you, Lord, for the gift of life. Full stop. Okay, good. it says what? It says tank is not found. Good. So we need to undo that here. We need to undo that here. You remember, it's a new word. It's not in the dictionary. It's not in the word. It's not in the dictionary we created. So that's a new word. So how do we go about that? List comprehension enables us to add conditions to within. Okay. Yeah, condition within. So excuse me for that. If we will check if chalk if chunk in invoker dot keys. So if it is found in chalk dot keys, it's going to pass this place. Else is going to put it as unknown word. Okay, unknown word. So later I told you, okay, this is a to access that we use self dot good. So I told you, I gave you assignment already, so implement that the unknown words should be kept, so that when we are decoding it, we'll be able to get the right word that the user used instead of giving us unknown unk. Okay, that's your assignment. I want you to think about that. Okay, all right, good. So let's do this. Let's do something of this nature. I don't know if we can break it this way. Yep, I think we can. Can we? I think we should be able to do it this way, so that because of the line, we'll be able to see what we're doing. Hope you are not confused. I'm just trying to make things tidy. Okay. Sorry. Okay, good. Now let's print it out and see if we have any error again. Thank you, Lord, for the gift of life. Good. Can you see now? We're able to undo that. Now, thank is a new word, so we use this to represent it. Don't forget we have unknown in the dictionary we created. Then we have you in our dictionary at index 525, and we have comma at index 483. Okay, and we have Lord as unknown as well in that our document. Okay, followed by 4 is 199 at index 199 in our dictionary. Okay, and we have I've given you two assignments actually. I say you should keep track of the unknown. Let it give us the right word like the user uses when we are decoding. And also I say you should read about CSV. I want you to write the vocabulary we created inside a file. Okay, so read how to do that. We have seen how to read file, so read about how to write to file. Okay, how to write dictionary to file, so use that. Okay, and if you can't do that, and believe you can do it, just read document. Okay, and I'm going to do some solution, of course, trust me for that, but however I want you to go through it yourself. Good. So we have the one for good. We have thanks, we have this, we have this, we have love, we have for here, we have the at the index 412. Gift as a word, no word. We have off as index 28. Life 325. We have life in our dictionary. Good. Full stop, which is the period 512. Good. Now we're able to achieve the aim. Okay, so we have gotten that. The next thing to do now is to decode encoded user input. And what does that mean? He say we should what? Inverse, that is reverse vocal keys to values and values to keys. So what we want to do now, instead of giving us number, we want to go back to the word used. Okay, so to do that, let's remove this print again. We are done with that. Let's move to the last, second to the last method. I wish I did not ask the print decoded value. Are we good? Should we remove it? Oh yeah, I'm going to give you as an assignment, another assignment. Yes, I'm not going to do it. So I'll okay, assignment. Use this as assignment. Okay, assignment. Good. So find out how to, you know, make sure that, okay, you are going to see what as your assignment is. Let me finish with us. The code. We want to decode now. So the code is going to be um, encoded text. So we want to decode the encoded text. Okay, now first and foremost, the instruction says we should what, reverse the vocab, and we have done it before, right? Is here we reverse the vocabularies. Can you see? Reverse the vocabulary. You can copy that. Let's copy that, and let's copy that. Let's copy that. Okay, and yeah, we've copied that. Okay, so we've copied that. Let's paste it here. Good. Yep. So now we are going to do some adjustment to that. Okay, now we can only have access from the KI because it's a class property. Okay, and this one now is this encoded text, so it's going to be here, encoded text. Good. So is this one of IDs that we're going to pass in here and give us the results. Okay, all right, good, 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 good. Now this is so we don't need to keep it in the variable, just return encoded. Okay, now good, I think we are done with the tokenizer. So let's say it first before we say we are done. Okay, so instead of printing decoded, okay, encoded too, we need to return that as well. So we don't need to keep it in, we can, you don't need to keep it, but however, to make things simple, let's just do it that way, return that. Okay, like I did for this one, you can see. So since we are returning that list now, meaning we are going to be collecting, we expect to get something from here. Say, let's just say encoded text is equals to this. So it saves the encoded. Now decoded text. Okay, let's say decoded text. We are going to pass in this now into this to reverse back to what user supplied. Okay, let's go back again, print. Okay, let's use the same, this prompt. Let me give gap here. Okay, let's rerun it. Let me rerun it. So I created that error. All right, let's rerun it. Good. Let's say this is, oh, thank you, Father, thank you, Lord, for the gift of life. Full stop. Then press enter. Cool, we have an error. It says what? It says key error for I if key error. Okay, I think we have this similar error. It should be inside the reverse ID, reverse um vocab, reverse vocab. Let me see. It should be, yeah. So how did we undo that? How did we undo that? Let me remember. How did we undo that? Was it here that we undo it? Okay, yeah. Okay, let's see. I didn't use list comprehension in here. So, but however, we can still use list comprehension to undo that. Okay. Let's think about that. If encoded, we have that number. We have IDs. So it's not actually IDs. So if if IDs, so meaning that, wait, let me think about this very closely. Mm, okay, we only assign in here, we didn't save the value. Oh, good. So this is what we do. Let's undo it from here. What I did here. So we're going to be passing this inside so that it's return, instead of returning. Okay, let me show you so that you won't be confused with what we're doing there. So let me do something. I'm not going to be calling this. Okay, since I will not call it, it won't throw error again. Let me just comment it here. Let me comment and show you why we are getting that error. Print encode text. So I want to use list comprehension. I don't want to use this if statement I use there, for loop with if statement. Okay, control structure, right? Okay, now let's run it again. I want to make sure that we use that also. Thank you. I'll use the same word so that it will get what we're talking about. Thank you, Lord, for the gift of life. Full stop. Good. Now you can see we have numbers, but here we have what? Characters of unknown UNK. So that's why it's throwing that error. That's IT error. So in order to undo that, let's get the number of this from the dictionary instead of using the string itself. So good. So let's run it again and see. Thank you, Lord, for the gift of life. Full stop. Now all are numbers now, meaning that the unknown, which is what? The unknown is 79. Where we have unknown, it's going to be 79. So there are 3 unknowns now. So now we can comment this, meaning we're going to get it now. So we don't need to. So let's print. Okay, no. We are yet to reverse. Okay, we have reversed that. All right, so let's print the coded text as well. We are printing. We say let's put something to demarcate. They say encoded text, user input, encoded user input, or query. Let's say query. All right, so nothing much about that. So decode the encoded user query. All right, nothing much actually. All right, good. Now let's run that and see this solution. Now this, okay, thank you. Let's use the same statement. Thank you. Can you say thank you, Lord, for the gift of life? Full stop. Enter. Good. Can you see now the encoded user query? We have all of this, right? Now the unknown has jumped to another index value. Can you see it now? However, if you can see now, the encoded user query, we now have the unknown, which is correct, unknown, for the gift of life. Full stop. Go. Congratulations. What I want you to do now, don't forget, is to join those words together to look as what user entered initially, not as list, but it should be as sentence. Okay, so that's what your assignment is going to be. That's assignment number 3, which is number this one. Okay, so I want you to do that. Don't forget we did it here, but I won't show you. So go through it and I implemented that. Can you see? I say back to the user input. So do that and submit your assignment. Happy birthday to me and to whosoever that is celebrating birthday on this day, August 23rd. Happy birthday. This is my gift for you. Bye for now.